Okay, everyone had calculated the check for deflection. Everyone had got the values for the deflection. That is 300 mm. सबको डेप्थ की वैल्यू मिल गई. Yes, everyone had done up till here. Yes, everyone had completed up till here. Should I proceed further? Okay. Okay. See now in your IS code, page number 38, I will show you the formula for the deflection and how to take the modification factor also. Is IS code is visible to you? See here. See here you are having the formula for deflection, that is 0.58 into Fy into area cross section of the steel required, that is AST required upon AST provided. And from this particular graph you have to take the modification factor for the tension reinforcement. As our percentage steel हमारा कितना था? Yes, how much is our percentage steel? Yes, anyone? Minimum percentage, how much our minimum percentage? How much it was? For check for deflection में minimum percentage की value कितनी थी? And FS comes up to FS की value कितनी थी? Yes, तनवीर. FS कितना था और minimum percentage की value कितनी थी? Yes, Mohit. FS was 220.58 and minimum percentage, how much the minimum percentage it was? 1.093. See, 1.093 was your minimum percentage and FS was 220 something. So somewhere here you might get the modification factor between 220 and 1.093. So हमने FS modification factor we had considered it as 1. Somewhere around between 0.8 and 1.2. So हमें modification factor की value कितनी मिली थी? 1. Depending upon percentage, minimum percentage and your value for FS. So understood how to take the value for the modification factor? Yes, you can use the formula also. Yes. Okay, now proceeding for the further step. Now design considering the T section. हमने जो अभी consider किया है that we had consider for the rectangular section. Now you need to consider for the T section. So first of all you need to calculate the width of flange, that is B suffix F. You need to calculate the width of flange, that is BF. For calculating that, again you are having the formula on the page number 39 of your IS 456-2000. So for calculating the width, you are having the formula that is L0 by 6 plus BW plus 6 into DF. So L0 is nothing but the total length, that is 6000 by 6 plus width width you are provided that is 230 and the depth is your 100. So from that आपको BF की value कितनी मिलती है 1830 mm. So calculate the value of B, width of flange, and after calculating let me know. After doing these calculations, let me know so that we can proceed further. It will comes up to be 1830 mm. Do these calculations. Yes, if any doubts you can ask. We are going to consider for the T section over here. We are going to design it for the T section. First of all, we are designing for the rectangular section. We are just going to check कि rectangular section से हमें कितनी value मिलती है और अगर T section consider किया तो कितनी values मिलती है for all these things, so that we can means for the next time हम decide कर सकते हैं कि हमें rectangular section consider करना है कि T section consider करना है, इसलिए हम दोनों से design करके एक बार check कर रहे हैं. Okay, everyone had done up till here. Everyone had got the value, that is 1830 mm. Okay. What about others? All the others had also done. Should I proceed further? Everyone had completed. Now your value for the width of lane should not be greater than LC by 2 plus LC by 2 plus BW. So your LC, that is the value for the LC comes up to be 2270. See your previous step, it is 2270 by 2 plus 2270 by 2 plus weight, that is 230, and the value comes up to be 2500. So it should not be greater than this value. So already our value is 1830 only. So we are going to consider the width of flange as 1830 mm. Do up till here and let me know after completing. completing, let me know. Yes, done. Okay. Now this is your T section. So the total depth is 450 over here. This is your XU. This is the value, that is 0.448 FCK, and this is your CU. So just draw this diagram for the T section that we are going to construct it for the design. Depth, yes, depth is 550. Yes, substitute the value for depth as 550. It is not 450, it is 550. Do this correction. The value for the total depth is 550 over here. Yes, Debas, please unmute yourself. Debas, mute yourself. After completing, let me know. Yes, done. Okay. Now calculation of XU, assuming XU is less than DF. For that you are again having the formula, that is moment of resistance will be equals to C into lever arm. So moment of resistance की आपको value already मिली थी, that is 202.5 that you had calculated in the previous step. So moment of resistance you had got, that is 202.5 into 10 raised to power 6. Again here the formula is there, that is 0.36 into FCK into BF into XU into D minus 0.42 XU. So the value for XU की value आपको पता नहीं है, so you need to calculate the value of XU. It should be less than the depth. So calculate, so then and only then your assumption will be correct. So calculate the value of XU by using this formula. Already the value for depth and the value for BF, that is the width of flange, you are having. So just calculate the value of XU, see whether the value of XU comes up to be 28.56 or not. Then and only then your assumption will be correct, that is XU is less than DF. Yes. See whether the value of XU comes up to be 28.56 or not. And if it is 28.56, it is less than the depth. Yes, completed. Have you got the value of XU? Yes, everyone had got the value for XU. After completing, let me know. Okay. So as our XU is 28.56, so whatever we had assumed, that is XU should be less than DF. So our assumption is correct over here. Now you need to calculate XU max. XU max calculate करने के लिए you are having the formula that is 0.48 into D. तो D आपका कितना है 550. So 0.48 into 550. So XU max आपको मिलता है 26 mm. Now XU is less than XU max. So hence URS. What is URS over here? Yes, anyone from you? What do you mean by URS? Yes, under enforced section. So it is under enforced section as XU is less than XU max. It is under enforced section. Again now CU equals to TU. So 0.36 FCK into BF into XU minus point equals to for tension. You are having the formula 0.87 FY into AST. So इसमें से आपको AST की value मिलेगी that is 1042.4 mm square. So you have to provide 2 bars of 20 millimeter diameter and 2 bars of 20 millimeter diameter. Wait, I will let you know. हम टी सेक्शन से भी डिजाइन कर सकते हैं और हम रेक्टेंगुलर सेक्शन से भी डिजाइन कर सकते हैं. दिस इज एक्स्ट्रा पार्ट. जस्ट ये फर्स्ट प्रॉब्लम है इसका, इसलिए मैं समझा रही हूँ आपको, इसलिए आई एम गोइंग टू टेक दिस. So we can design by rectangular section also, or we can design using T section also. Only the change आपका यहाँ तक ही रहेगा, मतलब सिर्फ AST में ही थोड़ा change आएगा. Otherwise all the values will be same. आपका जब AST उसने calculate किए थे, तो उससे जब AST कैलकुलेट किए थे तो आपको वैल्यू कितनी मिली थी 1267.7 mm स्क्वायर. सो उससे जो AST रेक्टेंगुलर सेक्शन से जब आपने AST कैलकुलेट किया था तो आपको एरिया मिला था 1267.7 mm स्क्वायर, और जब आपने टी सेक्शन से कैलकुलेट किया तो आपको एरिया मिला 1042.4 mm square. And all the other checks, that is the check for enforcement and the check for deflection, will be same as that of the rectangular section. Simply just for your understanding, I'm taking this. तो आप एग्जाम में आपको दोनों नहीं करना है. Either you can solve it by rectangular section, or either you can solve it by T section. Whatever you like, you can do designing for that. Okay, now understood, Anis? Okay. Okay, AST की वैल्यू मिल गई सबको. I hope all the others had also got the value for AST. Just write down a note over here that the design of shear reinforcement and the check for deflection is same as the rectangular section. So your design for the shear, that is the check for shear, and the check for deflection will be same as that for the rectangular section. So just write a note of that. Now here we have completed the design of beam B3. Now we need to design for the beam B1. Yes, everyone had noted up till here. I hope everyone had noted. So we'll proceed further for the design of beam B1. So for the design of beam B1, again we are going to consider the depth of beam as span by 10. So for B1, see your as the it is your 3 span. आपका जो बीम B1 है वो 3 स्पैन का है, इसीलिए D will be equals to the total span एक स्पैन उसका कितने का है 2500 का. See your previous diagram, फर्स्ट डायग्राम, वेरी फर्स्ट डायग्राम क्वेश्चन के बाद में जो हमने डायग्राम ड्रॉ की थी, सी द प्लान दैट यू आर ड्रॉन अर्लियर. सो as it is your 3 span and as the width of the depth of each of the span is 2500, so total span will be 2500 into 3 by 10, that will comes up to be 750, and the width is 300 mm for the beam. Since the wall thickness is 230 mm, always the width of the beam is greater than the wall thickness. So wall thickness itself mentioned in the question that wall thickness is 230 mm. So width of the beam you have to consider it as 300 mm. So do first of all calculate or do the calculations for the depth, then we shall proceed further for the calculation of loading for the beam B1. And if any doubts, you can ask. And after completing, let me know. Okay, done. Everyone had got the depth. Should I proceed for the loading calculations? Okay. So now calculation of loading. So first of all, we need to calculate for the beam, self weight for the beam. So for the self weight of the beam, we are going to consider the depth of beam and the width of beam. So width of beam हमने कितना लिया है 300 mm. As we are going to convert it in meter, so it will be 0.3, and the depth उसका कितना है 750. Again we are going to convert it in meter, so it will be 0.75 into density into factor load, that is the factor of safety, that is 1.5. So सेल्फ वेट ऑफ द बीम आपको मिलता है 8.437 किलो न्यूटन पर मीटर. देन अगेन वॉल लोड, थिकनेस ऑफ द वॉल इज 0.23 एंड 3, क्योंकि 3 वॉल है इसलिए मल्टीप्लाइड इट बाय 3 into 20 into 1.5. So wall load comes up to be 20.7 kilonewton per meter square, and the total load will be 29.137 kilonewton per meter. That is approximately will be equals to the 30 kilonewton per meter, and the point load again is there पॉइंट लोड भी अटैक्ट हो रहा है फॉर द बीम B3 दैट इज ऑफ द 135 किलो न्यूटन. ये जो हुआ दिस इज योर टोटल लोड एंड अगेन वन पॉइंट लोड एडिशनली इज एक्टिंग ओवर देयर ऑफ द 135 किलो न्यूटन. So do the calculation for loading. And after completing, let me know so that we can proceed further. Yes, do the calculation of loading. Okay. All of you are done? Yes. Now to proceed with the movement and the shear calculation. So calculation of movement, bending moment and the shear force. Yes, can anyone let me know ये bending moment और shear force की value कैसे calculate करना है? Yes, anyone from you? How you are going to calculate the bending moment and shear force for the beam B3? ये 548.43 किलो न्यूटन मीटर कैसे आया और shear force की value 247.5 किलो न्यूटन कैसे आई? Yes, anyone from you? Yes, no one? So this is homework for you. So just note down the values for shear force and bending moment. If आपको अगर नहीं समझा कैसे आया, so I will let you know in next lecture. So just note down the values for the bending moment and shear force. It is very simple how to calculate the bending moment and shear force. So for now, just note down these values and let me know in next lecture कि कैसे आया. Okay, noted. And this is a small homework for you. Okay, noted. Should I proceed further? Now you need to check whether your beam is singly reinforced or the doubly reinforced. Yes, अनीस आपको भी नहीं पता है बेंडिंग मोमेंट और shear force की वैल्यू कैसे आई है? Yes, can you tell me how you had got these values for the bending moment and the shear force? Then I am asking you ना बताओ कैसे आई? Which formulas you are going to use to calculate the bending moment and the shear force? Yes, 2-point load and UDL is there on the beam. So for point load, what is the formula for the shear bending moment and what is the formula for the shear force and what is the formula for UDL for the bending moment and the shear force? You can unmute yourself and you can speak if it is not possible to write it in the chat box. Yes, anyone? Yes, Anis, you can unmute yourself and you can speak. For UDL,
मोमेंट का तो WL स्क्वायर बाय 8 आ जाएगा UDL का, और मैं उससे सिंपल तो रहेगा कि रिएक्शन निकाल लेंगे और रिएक्शन से मोमेंट निकाल लेंगे सेंटर पे, फॉर्मूला की जरूरत ही नहीं है। और शेयर के लिए तो सिमेट्रिक है, तो हाफ ऑफ द लोड विल गिव यू शेयर का वैल्यू VU।
yes. Either you can first of all calculate the reactions and then you can calculate the bending moment and shear force, or either you can use the formulas. Anything you can do. So calculate, see whether आपको ये जम रहा है कि नहीं, नहीं तो I will let you know in the next lecture. Okay. Now you need to check whether the beam is singly reinforced or the doubly reinforced. So for that you are having the formula, that is moment of resistance will be equals to 0.138 BD square into FCK. So 0.138 D square into FCK. Here B is your 300 and the D is 700. So calculate the moment of resistance. Moment of resistance should be less than the moment, the bending moment. So hence this condition is satisfying over here. So doubly reinforced section is this. हमारा डेप्थ कितना आया था, 750 आया था, तो हमने 700 क्यों प्रोवाइड किया है यहाँ पे? Effective depth we are going to consider it as 700. We are going to assume the cover it as 50. So 750 minus 50 that will be 700. That's why यहाँ पे depth की वैल्यू कितनी आई है, 700 आई है. Okay, done. Everyone had completed up till here. After completing, let me know. See whether moment of resistance value you are going to get it as 405.7 kilonewton meter or not. Yes, complete. Everyone had got the answer for moment of resistance. Yes, done. Okay. So now you need to repeat the same steps. That is, first of all, you need to check for the longitudinal reinforcement. For longitudinal reinforcement, again you need to consider the balance section. So balance section में आप क्या consider करोगे? Again the same formula that you had used earlier. That is the C1 into L into A1 plus C2 into L into A2. So the same steps you need to repeat and you need to calculate FSC So FSC आपको मिलेगा 616.67 MPa. Then you need to consider the check for the shear reinforcement as well as you need to check for the deflection. So try this. If you will not get, I will take in the next lecture. We are running short of time. Last 2 minutes are there. आपको FSC की वैल्यू मिलेगी 616.67. FSC you will get it as 616.67. Try by your own. This is the same as you have done for the beam B1. B1 के लिए जैसे किया था same for this beam also you need to calculate. So देखो calculate करके आपको सारे आंसर्स मिलते हैं कि नहीं. ASC आपको मिलेगा 617.8 mm square. ASC will be 617.8 mm square and AST required आपको मिलेगा 2609.06 mm square. 2609.06 mm square. So as we are having very less time, we'll stop over here. For today we will stop.